Alright, what up guys? It's me, and welcome to another video. So, as you can probably tell by the title and thumbnail of this video, I've created a Wordle Solver, and I say I, but it was me with the help of my professors in the class, created a Wordle Solver, and it's pretty cool to me because I did some front-end work with it in Unity. So yeah. Let me see. Can I get the right one? No, I can't. I apparently don't have a button for that. Anyway, yeah. Welcome to my rundown of my Wordle Solver. Don't mind me drinking some liquid IV. I've got to make sure I hydrate. If any of you guys are ever wondering what I drank in videos, most of the time it's probably liquid IV or soda. But yeah, so welcome to Wordle Solver in intercept programming. So again, like I briefly mentioned earlier, this algorithm is not mine. I am not going to be running through how this works. I will run through sort of the basics, but I'm not going to run through the code because it's not my code. I didn't come up with the algorithm. I didn't do a lot of the data gathering for it. So I'm not going to run through that because I would be stealing somebody else's work, and I'm not going to do that. What I am going to run through is sort of how I incorporated it into the program that I built. So to start, what is ASP? You've probably seen that word a couple times. ASP stands for answer set programming. So it is sort of like an alternative approach to AI, where basically it works on what you know. So you define facts and then you give it constraints or rules to eliminate answer sets that don't meet those constraints. So that's called a hard constraint. And then if you have a soft constraint, those optimize the answers. So you give it essentially a weight that is a cost of choosing that solution, and you either maximize or minimize that cost. And it chooses an optimal solution based on that. And this slide is actually wrong. I don't know where ASP was developed, but I know DLV, which is what the classes I took in Italy were on, were developed by researchers in Italy and Austria. In Italy, I know it was University of Calabria. I forget how to say it in Italian. Less that I forget, more so that I don't want to butcher it live on the internet. But yeah, DLV was developed by Italian and Austrian researchers, and that stands for data log with disjunction. So I want to walk a little bit through how does the solver work. I'm going to tell you sort of the ideas. I'm not going to walk you through the code and fully explain it, because again, it's not mine. But essentially, we take all the valid solutions that New York Times lets you input as answers. And we put them in a database, and we say it's valid, and then we have the word, and then we have first letter, second letter, third letter, fourth letter, fifth letter. We have that for about 3,500 words. Those are all words that could be right solutions. And then we take the frequency of each letter within a word. So as you can see there, it's for A. So the letter A comes up 191 or 198 times in the first letter, then 471 in the second letter, and so on and so on. After that, we feed the algorithm a set of clues, which is where Unity comes in, and I'll talk more about that in a second, to eliminate answer sets based on positions. So if you have a gray square, that's the last letter, that would say that Y cannot be in position 5. If you have a green square in the center, and it's E, that would say that E is in at position 3. And then if you have a yellow letter, you would say that, let's say A is yellow. You would say that A is in, and then not at the position that it needs to be. So, moving on, why Unity? So the program that I wrote in Unity, and I did all of the front end on this essentially, so all of the UI and all of what makes it write to a file. It essentially is a user-friendly interface that will write the clues. So back before on this slide where I had like out at Y5, if you have something that's gray, that means it can't be in any position. So you have to write that for 4, 3, 2, and 1. Not that you can't just manually write it out in a file, but let's be realistic. If I was publishing this somewhere, which I'm not, no one would want to do that. And no one would want to have to go in and access those files and update that to be able to use it. So with Unity, I essentially write the EDB, which stands for External Database. It's essentially in a different file than the file that actually does the solving, so that I can feed different data sets into it if I want to, and sometimes get different results. Also in Unity, I can use embedded ASP. So embed ASP, EmbASP, embedded ASP, regardless of how it's spelled, embedded ASP essentially means that you can use answer set programming and its language in C# or Unity in this case, Java and Python to make these programs more accessible. I can tell you it is a pain to try and run these programs through like an IDE, and if you're publishing some software that uses this, you probably don't want people to have to open up a command prompt or a terminal and run some commands to be able to get it to work. So this allows you to make like a Java program, or in this case, a Unity program where you use DLV to find, or whatever answer set programming language you're working in, to find solutions to something, and you do it that way. And also, it makes it an all-in-one system. With the use of embedded ASP, it's now a standalone software. Before, when I was running it on my laptop, I would have had to run it on so many things, and I would have needed like 6 files, but now I can feed all those files into one, let the user do its thing, and it's its own standalone software, which is kind of cool. So I'm going to demo this. I'm going to see if I did my OBS correctly. So, awesome. That works so far. Okay. So, this is what the Wordle Solver looks like. Basically, you have your Generate Word button over here, then you have your Clear Clues, and here you have the Wordle grid where you can input the feedback you get from Wordle. So, I'm actually going to solve a Wordle here live with you guys so that you can see how this works, and then I'll run into the nitty-gritty code. First step is to generate the first word. This takes a little bit of time. It doesn't take much, but it has to go through all of the guesses and figure out what the best one is. So it is generating the guess, and as you can see down here is where that guess will be shown. While it generates that, I'm going to move us over into Wordle. So now, perfect. I'm going to go out of dark mode to make it easier for myself. Oops, that's OBS. But yeah, so we have Wordle, and I can tell you that the first guess this thing always gives out is samey. So, switching back over to our Wordle Solver, we have S, and we're going to set it as gray. All right, sorry about that. I had a little hiccup, but we got it. So, if we go back to Wordle, we can see that S is green, A, M, E, and Y are gray. So I'm going to input that in here. S as green, then A, M, E, Y as gray. Now I'm going to generate another word, and as you'll see down here, it shows us sound. So we're going to come back up here to Wordle. Okay, so that tells us a lot. So we come back down here to the Wordle Solver. The nice thing about answer set programming is it ignores duplicates. So I can put S in there twice, and then O, U, N, D, generate word, we get shirt. So now we come back up here and hit shirt, and that tells us a lot of stuff. So knowing that, we come back down here, S, H, I, R is gray, and T is green. So now we generate another word, and we get stilt. So we come back to Wordle, type in stilt, and as you can see, it got it in 4, which I think is pretty cool. So I'm going to switch over to VS Code and talk a little bit about how this works. So starting all the way from here, we just have a simple UI manager. We have the answer text. We have the object that handles the solving algorithm. And then we have an update button handle that updates the UI screen for where we're inputting the letters. Up here, we literally just assign the component, nothing too crazy. Generate button click basically generates a solution and makes it so that that solution gets displayed where it says, where it said samey and sound and all of those things. And then the got it click is something I never ended up using. That was just if you got it, it was going to clear the clues. So going into the self script, this is how it works. Actually, that is not what I thought this did. If you can't tell, it's been a little bit since I wrote this code. I've been working on this for a while. Essentially, up here, you just define a button, the panel transform, so the transform of the entire table, I believe. Yeah. And then the color update panel, which is that little UI you saw where I entered in the letter and chose the color. On start, you basically just assign things from variables to the actual things within the Unity scene. Nothing happens in update, and then when a specific cell is clicked, you set the color update panel to true. Then you get the name of the game object, which is either like 1x1, 1x2, 1x3, being row, then column. And basically it splits it before and after the x, and this just goes through and gets the column number, and then here you update the color panel with what the current cell is. So this is where a lot of the UI magic happens. This is a whole bunch of just defining things. In the start, you set the path to be encodings / clues.dlv. So clues is like the in at and the out at. Then you update, you set the letter text to lower, and you set the color text to whatever the color text here is. that color text, it's really hard to explain without Unity up in front of me, but essentially, it's basically where the drop-down menu option is displayed. The option you've selected is displayed there. So we get that. Then we have the set current cell function, where as soon as we pass here, we pass the cell name so that we can search for it, and then you have the column for where we write out to the file. Then in the update button function, that's the little update thing you click when, or here, actually, who am I kidding? I can show you. Let me switch back over to here. If I go here, green is the color text right now, then yellow, and this update button function does a lot more than you would expect it to. This is the code that we're looking at currently for that. So we get the child, which is essentially the current cell. We then go in there and we get the square and the label. So the label is just where the letter shows up, and then the square is the image. That's how we change the color. And then we go, if color is equal to green, change the color to green. You set the text color to black because that's what shows up the most. And then you write out in at plus the letter, plus a comma, plus the column, and a new line. That is how you write the clue. For that, for yellow, it's essentially the same thing, except you have to define that the letter is in, but it is out at a certain position. And then if it's gray, it is the exact same thing, and you're just writing out at plus the letter plus 1, 2, 3, 4, 5, and that says that no solution can contain that letter. Then after that, you just write a new line after every set. You set the label text for the cell to be constantly uppercase, and then you set the panel false, and that's that. We also have a clear button, which basically just writes nothing to the file, which in effect clears it. Or it doesn't write nothing, it writes a space, which visually looks like nothing, but that one character is enough to just clear the file. And then we have one here where we have a for loop here where we go through and just set all of the images back to be the color of white, and we set all of the text back to be nothing. So that is how the update screen works, and what I want to do with this a little bit is I want to show you guys what went into making the AI solver part of it work. So these are all the imports that I needed to use from embedded ASP. Then here, I just have typical Unity imports. And then, oh, so that's why that's not working. But basically, you have the path, which is defined down here. But basically, so that's where the DLV runnable is. But essentially, I have all of these files, and I'm adding it to one big program with the EDBs first, followed by the IDBs. So the data, then the rules, and then I'm telling it to run. And this is a bunch of stuff just to be able to format the answer correctly. The line of answer sets equals handler.startSync runs the program, and then everything else down here is just formatting. But without showing you the actual Wordle Solver or any of the EDBs, you can see it's overall a couple of lines of code to get this to work. Granted, it took a lot longer than a couple of lines of code should, but all that being said, it was relatively easy to implement. So guys, hopefully you found this really cool. If you have any questions, feel free to leave them in the comments. And I will see you guys in the next video. If you enjoyed it, Please be sure to subscribe, like, do all those things. And yeah, see you guys next time. Bye.